Assalamualaikum, my name is Akil Kuala Marikanan. My matric number is CN220352. Okay, so this is the introduction for our project. Okay, after the 1974 Arab oil embargo, US Congress establishes corporate average fuel economy standard to increase the fuel efficiency of new vehicle. Major US car manufacturer, including Ford, developed their own policy and technology to meet the standard. Ford introduced the EcoBoost engine in 2009, starting with the 3.5-liter EcoBoost V6 in the Ford Taurus. Over the year, Ford continued to update and develop various petrol engine variants within the EcoBoost family, incorporating technology like turbocharging, variable cam timing, and direct fuel injection to improve efficiency and remain competitive. However, Ford faced challenge in maintaining quality control for its EcoBoost engine.
So, according to the issue reported by the customer of the 2.7 liter and the 3.0 liter V6 EcoBoost engine, the car experienced engine failure without any symptom in the first 2,500 miles of the operation miles. The inspection was conducted by the NHTSA. Upon the inspection, the NHTSA discovered that the internal valve of the engine was failing, which was fractured in the first 2,500 miles of use. So the fracture of the internal valve was due to the improper quality control on valve writing process from the provider of the internal valve of the Ford. So the high heat condition was causing the intake valve to be changing in terms of microstructure, which caused the overall intake valve to be fractured, especially in the groove region. And also, the light steel chrome was chosen to be used in the construction of the intake valve, which was later discovered that the material also causing part of the was the reason causing the intake valve to be fractured.
Assalamualaikum, my name is Syaminu Muhammad, CN2033. So, now I will explain the impact of the engine defects on Ford manufacturing and product quality and operational efficiency. So, the issue involved a total of 90,756 vehicles across multiple Ford models. The root caused by brittle intake valve, which led to catastrophic engine failures during normal driving condition. From a manufacturing perspective, Ford had to urgently allocate production resource and apply rework protocol which disrupt the workflow and delay engine assembly and distributions. So this suddenly create a strain on the supply chain, which is affecting the inventory and production planning. So replacing the faulty valve was impractical as it required a complete engine disassembly and rebuilding, so which introduced high repair costs. In terms of product quality, this failure damaged Ford reputation for reliability. Many customers experienced failure within the first 20,000 miles, which leading to low resale values and reduced interest in affected models. So according to industry data, over 800 engine replacements were conducted and 487 warranty claims were linked to the valve train issue. So this result in a 5 million lawsuit filed by dissatisfied Ford Bronco owner who claimed Ford failed to disclose the defect before purchase. As a result, consumer trust and brand loyalty declined, especially for models popular like the F-150 and Bronco. So the case received wide attention from the National Highway Traffic Safety Administration (NHTSA), which launched an official investigation into Ford quality control.
Okay, let's move to the strategy and solution implemented by Ford to overcome and identify issue. Initially, Ford provided engine warranty claim for affected customer but did not announce a recall. However, due to investigation by NHTSA and customer complaint, Ford issued a major recall offering free engine replacement and standard warranty coverage. Ford revised its supplier manufacturing protocol, focusing on heat treatment and grinding process to improve valve durability and prevent future failure. Additionally, quality control checkpoints were also introduced to detect defects before vehicles were distributed. This measure helped restore customer trust and reinforce Ford commitment to quality and safety, enhancing its reputation for taking responsibility and prioritizing customer satisfaction. Ford also implemented a customer communication strategy, proactive notifying affected owner, providing support and guiding them through the replacement process. This strategy reinforced Ford's reputation for transparency and commitment for customer service.
This slide highlights the key point of the intake valve failure issue in Ford 2.7 litre and 3.0 litre EcoBoost engine. A total of over 90,000 vehicles were affected across several major models, leading to hundreds of warranty claims and engine replacement. The problem triggered a $5 million class action lawsuit and an official investigation by the NHTSA. Ford responded with a formal recall, free engine replacement, and extended warranty coverage. Internally, they upgraded their manufacturing process, including better heat treatment and quality checks. While consumer trust was temporarily shaken, Ford corrective action helped to partially restore their reputation. So, in this next slides, it shows the figures of the statistic Ford Motors Lincoln vehicle sales from year 2016 to years 2024. So in this slide, Ford EcoBoost engine issue, especially in the 2.7 litre and 3.0 litre models, reveal major lesson for the company and the wider automotive industry. A small valve defect caused engine failure, damaging Ford's reputation and prompting industry-wide change. Key lesson learned: material and process must align. Using a lightweight alloy without proper heat treatment lead to valve failure. This shows how critical it is to match material with precise manufacturing processes. So, first, listen to customer feedback early. So, Ford delayed action, treating early failure as isolated. This escalated into a lawsuit and investigation. Acting on customer complaints early can prevent larger problems. And the second, one small part can cause big damage. A single valve failure damages entire engines. This proves why component level testing is vital during development. The third point is strong supplier oversight is essential. The root cause come from supplier error. Automakers must monitor supplier quality closely with strict process checks. Next, layered quality control works. Ford added more checks on the engine lines after the recall. This showed the needs for continuous quality control from start to finish. So in the industry implications, smarter material use. Other automakers are now more careful with lightweight alloys in engine parts. So for the next, more use of reinforcement kits. So the repair tools like helicoils are being used more often to fix and prevent threads issued in aluminium heads. The next point is stricter heat treatment standards. Manufacturers are tightening control over machining and grinding to avoid similar failures. The next, better customer support system. Companies are improving recall communication, offering tools like online VIN checks and faster service bulletins. And the last one point is shift to predictive quality. Automakers now use data analytics and AI to detect defects early before cars leave the factory. So for the conclusion, both slides, the EcoBoost failure reminds the industry that innovative must be matched by strong quality control. It has reshaped how engines are built, tested, and supported, making reliability a top priority. That's all from me. Thank you.